All right, hello and welcome. In this video, we're going to be talking about inverse functions. So basically, to find the inverse of a function, all we're going to do is take the values of the domain and range and switch them. So to put it simply, when you do an inverse, all we're going to do is switch x and y. So if I was given these 4 points to represent my function, and I wanted to switch it to its inverse, right? The 1 and 7 switch to become 7 and 1. The -1 and 5 become 5 and -1. The -3s technically switch, but they're the same point, so we wouldn't be able to tell. And then for the final point, the -5 and -8 would switch. So when we're given ordered pairs, that's really all we need to do. When we are drawing the graph, what we're going to do is put both the new points and the original points on the same graph and see if we notice some kind of pattern. So the first point I need to graph is 1, 7. Then I'm going to graph -1 and 5. I'm going to graph -3 and -3. And then -8 and -5. So if I connect these points, that's my graph for my original function. So now I'm going to go ahead and graph my inverse function. So I'm going to graph these points over here. So I'm going to have 7 and 1. I'm going to have 5 and -1. Still going to have -3 and -3. And then I'm going to have -5 and -8. So let's see what happens when we connect these points. So my blue graph represents my original function. My purple graph represents my inverse function. And to mark it as an inverse, I'm just going to put this little -1 next to the letter F. And so as we look at these two graphs, the blue and the purple, what we should notice is that the graph is flipped across this diagonal line. So anytime I graph both a function and its inverse on the same axis, the graphs should be reflected diagonally. All right, so let's look at how we're going to use this to solve some problems. So we said an inverse means that all we're doing is switching x and y. So when I am given something like this, what I'm probably going to do is label my x and my f of x as it's written. And then to do the inverse, I'm going to switch the two columns. So this becomes my x, and this becomes my inverse. Notice that I can do the same thing with the graph. So if you're having trouble seeing it with the function mapping with the arrows, what you could do instead is make a table using the points on the graph that they give you. So I'm going to go ahead and list the points that I can see. So it looks like -2 lines up with this point on the x-axis and 3 on the y-axis. At -1, I'm at 0 on the y-axis. At 0, I'm at -1 on the y-axis. At 1, I have another 0. And then at +2, I have another 3. So those are the points for my function. To get the inverse, I'm going to take the function and I'm going to reverse the x and y column. So anything that was previously in the x column will now be in the y column. So my new y's will be -2, -1, 0, 1, and 2. And my new x column will be 3, 0, -1, 0, and 3. So now that I've got my inverse, I'm going to take that table and use it to answer these questions down here. All right, so the first one says f inverse 3. So whatever's in the parentheses is what I'm looking for in my x column. So if the 3 is in the parentheses, I'm going to find where that number is in the x column, and I'm going to copy down the number that's next to it. So it should be equal to -2. If I see f inverse -1, again, the -1 is in the parentheses. So I'm going to copy down the 0 across from the equals. For an example like number 5, I notice the 0 is across from the equals. So that means I need to find a 0 in the y column and copy down the number that's in the x column. And so for one more of those, if I'm looking at number 6, the 1 is across from the equals. So I'm going to find a 1 in the y column and copy down the number that's across from it. So my x would equal 0. So that's how we use inverses with graphs and tables. In the next video, I'm going to show you how to use an inverse with an equation.